Homework 23 starts off with sketching the graph of a secant or cosecant function. The secant function is the inverse of the cosine. The cosecant function is the inverse of the sine. So what's going to happen is, if I just start with a sketch of a graph of the cosine curve, my normal cosine curve starts up, has a period of 2 pi, and has its minimum at pi, maximum here, and looks something like this. Remember, we have zeros here. Well, if I'm going to do my secant curve, for wherever I have a 0 on my cosine curve, I'm going to have something that's 1 divided by 0. So I'm going to have that asymptote there. That's that imaginary line that my graph is not going to cross. My secant curve then is going to touch the same point that it touches here, but instead of curving this way, it's going to flip it upside down and it's going to curve this way. So my secant curve is going to look something sort of like that. If I would do my sine curve, my normal sine curve starts at 0, 0, crosses at pi, also crosses at 2 pi, and has its amplitude here, going like that. So for my cosecant curve, wherever there's zeros again, I'm going to have an asymptote because I would have something divided by 0. It's the inverse or the reciprocal. And again, it's going to touch this point, but instead of going this way, it's going to go this way and this way. So, secant curve, cosecant curve. So when we are going to graph a secant or a cosecant curve, we're going to do it just like we were going to either graph the cosine curve or the sine curve, and then we're going to adjust it to the inverses. So I think about what I do when I was going to graph the sine, or this one is cosine. So for my normal cosine values, we said that we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. At 0, we're normally up at the amplitude. At pi over 2, we're normally at 0. At pi, we're at negative the amplitude. At 3 pi over 2, we're normally at 0. And at 2 pi, we're normally at the positive amplitude. So I'm going to take the 1 times the amplitude, negative 1 times the amplitude, and so forth. First of all, I have to figure out my shift here. I have my 1/2 for my b value, and so I'm going to have 1/2 x equals 0, 1/2 x equals my pi over 2, 1/2 x equals pi, 1/2 x equals 3 pi over 2, and 1/2 x equals 2 pi. Just like we did when we were going to do the cosine curve, we set this equal to each of our normal values for x and solved. So to solve these, we're going to times 2 on all of them. So 0 times 2 is 0. Here 2's would cancel out, I get pi. Here I'm going to get 2 pi. Here my 2's cancel out, I get 3 pi. And here 2 pi times 2, I get 4 pi. So if I have a 1, I'm going to take 1 times my amplitude, so I'm going to have 2. If I have a 0, I'm going to have an asymptote. Here I have negative 1 times my amplitude, so negative 2. Here I have 0, so that's where I'm going to have an asymptote. And here I have a positive 1. 1 times 2 is going to give me 2. So at pi, 1, 2, 3, 4, so at pi, this would be 1 pi, I have an asymptote. At 3 pi, I also have an asymptote. Now they're going to tell me to do 3 consecutive asymptotes. I only have 2, but I can figure out where the next one is because every 1, 2, I'm going to have another asymptote. 1, 2. Here's my next asymptote then. 0, 2, I have a point. At 2 pi and negative 2, I have a point. Sometimes you have to use the plot point tool to get these on here, depending on what they have for the graph. And at 4 pi, I'm at 2. So I'm going to put the three asymptotes. I'm going to put at least 2 points, one on each side of the middle asymptote. If I've got more than 3, that's okay. I'm then going to hit the graph button. And when you hit the graph button, it's going to start putting the rest of my graph on there for me. You might even see this one over here. Oh, I drew it up a little high. Because it's going to hit at 2. And so you're going to see a graph that looks something sort of like that. They want you to have at least 3 asymptotes and at least 2 points, one on each side of that middle asymptote. You can have more points on there if you want when you draw it on Alex. So number 2, we're going to do the cosecant. The cosecant is the inverse of the sine, so you want to think about your normal starting values for the sine curve. So again, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Normally the sine curve starts at 0, ends at 0, the middle is at 0, and normally it goes up first and down second. So we have those values in there for our normal sine curve. Here we are going to set 3x equal to each of those starting x values. So 3x equals 0, 3x equals pi over 2, 3x equals pi, 3x equals 3 pi over 2, and 3x equals 2 pi. So in order to solve that, we would be dividing by 3, which since we have fractions is multiplying by 1/3. So I'm going to multiply each of these by 1/3 to solve. So here I get 0. Here I'm going to get pi over 6. Here I'm going to get pi over 3. Here the 3's cancel out, so I get pi over 2. And here I'm going to get 2 pi over 3. So wherever there's a 0, I'm going to have an asymptote. I'm going to have an asymptote here, an asymptote here, and an asymptote here. Because for the sine curve, the beginning, the middle, and the end all cross at 0. Then I'm going to take 1 times my amplitude 2/3, so it's going to go up to 2/3 first. Negative 1 on my amplitude, so negative 2/3 second. So my asymptotes are at 0, at pi over 3. Pi over 3, let's see, what units are we in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 between 0 and pi, so each one is pi over 12. If I have to do pi over 3, making my equivalent fraction, 3 goes in there 4 times, so I need to do 4 pi over 12. So 1, 2, 3, 4 marks, that's where my next asymptote is. Which means 1, 2, 3, 4 marks would also be my next asymptote. 2 pi over 3. If I put it over 12, 3 goes into 12 4 times, I'd have 8 pi over 12. 1, 2, 3, 4, 5, 6, 7, 8, right? Pi over 6 is up at 2/3. This is one we'd have to use the plot point tool. That one that looks sort of like a little graph with an X, we'd have to type in the ordered pair because it's at 2/3. Pi over 6 would be 2 pi over 12. So halfway between here and here, going to be up to 2/3. We'll just estimate it, but on Alex you have to have the plot point tool put it on there. And then at pi over 2, which would be 6 pi over 12, but happens to be marked, we'd be at negative 2/3. So once we've got that, we can hit the graph button, and then Alex is going to continue on, and it would actually fill in the rest of the graph to the end, but it's going to look something sort of like that. The third one, again, we are going to do a secant curve. The secant is the inverse of the cosine, so we think about our normal values for the cosine function. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. 0, we usually go up 1. Pi over 2, we're at 0. At pi, we're down 1. At 3 pi over 2, we're at 0. And at 2 pi, we're back up 1. We have 1/2 x to equal each of our values. So 0, pi over 2, x equals pi. Yeah, that was right. Getting ahead of myself. 1/2 x equals 3 pi over 2, and 1/2 x equals 2 pi. So in order to solve this, we would be dividing by 1/2, which is multiplying by 2. So times 2 on each of those. So 0 times 2 is 0. Here, 2's cancel out. I get pi. Pi times 2 is 2 pi. Here the 2's cancel out. I get 3 pi. And 2 pi times 2 is 4 pi. Here, I am going to go in the negative direction first. 1 times negative 2 is going to give me negative 2. Here I'm going to have an asymptote. Here, negative 1 times negative 2 means I'm going to go to positive 2. Then I'm going to have another asymptote. And then 1 times negative 2 means I'm going to go to negative 2. So I have an asymptote at pi. And I have an asymptote at 3 pi. Which means, if I could draw straight, I also have an asymptote at 5 pi, right? 0, I'm at negative 2. At 2 pi, I'm at positive 2. At 4 pi, I'm at negative 2. So again, once I hit the graph button, it's going to draw in my secant curve for me. Four, 5, and 6, we're still graphing the secant or the cosecant, but now we have a phase shift to our graph. And so, again, we're going to do it just like we did when we graphed the sine and the cosine. We're just going to adjust it to the inverse once we do our problem. So, secant is the inverse of the cosine curve. So we have 0 pi over 2 pi, 3 pi over 2, and 2 pi for our normal starting values. For our cosine curve, we normally start up at 1, end at 1, have negative 1 in the middle, and our zeros are between those two things. So we want to take here the 3x minus pi and set it equal to each of these values. So I'm going to set it equal to 0. I'm going to slide over here a little bit so I have some writing room. Pi over 2, pi, 3 pi over 2, and then equal to 2 pi. So when I solve these, first I'm going to add pi to everything. So add my pi. So 0 plus pi is pi. Pi over 2 plus pi. 1 pi plus 1/2 would give me 3/2. So 3 pi over 2. Pi plus another pi, 2 pi. 3 pi over 2 plus pi, which is 2 over 2, would be 5 pi over 2, or 3/2 plus 1 if you need to use your calculator. 2 pi plus pi, 3 pi. Once I've added pi to everything, I still have to get rid of my coefficient, so dividing by 3, which is multiplying by 1/3. So I'm going to times everything times 1/3. So this is just going to give me pi over 3. This is going to give me, the 3's cancel out, pi over 2. Here, nothing's going to cancel out. I'm going to get 2 pi over 3. Here, nothing's going to cancel out. I get 5 pi over 6. Here, the 3's cancel out. I just get a plain old pi. So, cosine curve normally starts up, but since this is a negative, I'm going to have a negative 1/2. Then I have my 0, which on my secant curve is going to be my asymptote. Then I have negative 1 times negative 1/2, so I'm going to go up to positive 1/2. Then I have a 0, so again I'm going to have my asymptote. Then I have 1 times my -1/2, so -1/2. So my asymptotes are at pi over 2, and my other asymptote is at 5 pi over 6. So I can't go to the right to get to my next asymptote. I'm going to have one back here. I have 1, 2, 3, 4 spaces. So 1, 2, 3, 4 spaces. Puts me at pi over 6 for my other asymptote since they want 3 of them on there. So at pi over 3, I'm at -1/2. Again, you'll have to use the point tool to get it exactly where it goes. 2 pi over 3, I'm at a +1/2. And then at pi, I'm back down to -1/2. And so again, when you hit the graph, whoops, I better draw that the right way. That one went down first. It was at -1/2. My secant function is going to look something sort of like that. So number 5, this time we're going to do a cosecant function. The cosecant is the inverse of the sine, so we think about our table for sine. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine curve starts at 0, ends at 0, the middle is 0, normally goes up first and down second. And so here's my shift. I'm going to say x minus pi over 2 equals 0 equals my pi over 2 equals pi equals 3 pi over 2 and equals 2 pi. On this one, to solve it, all we're going to do is add our pi over 2. Since we don't have a coefficient in front of our x, makes it a little shorter. So add my pi over 2 on each of these. So 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, which is pi. 1/2 plus 1/2 is 1. 1 plus 1/2 would give me 3 pi over 2. 3 pi over 2 plus 1 pi over 2 is 4 pi over 2, which is 2 pi. And 2 pi plus pi over 2, this would be 4 plus 1, so 5 pi over 2. So 2 plus 1/2, 2 1/2, or 5 halves, right? Sine curve is the inverse of the cosecant. So if this is a 0, this is going to be an asymptote. This is going to be an asymptote. This is going to be an asymptote, starting middle end. Normally we go up. 1 times 2 is 2. -1 times 2 is -2. So at pi over 2, I have an asymptote. At 3 pi over 2, I have an asymptote. At 5 pi over 2, I have an asymptote. At pi, I'm up to +2. At 2 pi, I'm down to -2. And when I hit graph, then I'm going to have the graph of my cosecant curve. And number 6, we're doing the secant curve again. The secant is the inverse of the cosine. And so my normal cosine, 0, pi over 2, pi, 3 pi over 2, and 2 pi. My normal cosine curve starts up. In the middle, it's down. At the end, it's up. And in between each of those, we're at our zeros. My shift, here I have x plus pi over 2. We want it to equal 0, to equal pi over 2, to equal pi, to equal 3 pi over 2, and to equal 2 pi. So again, on this one, all we need to do is subtract our pi over 2. Again, we don't have a coefficient that we have to worry about dividing by. So minus my pi over 2 to solve each of these. So 0 minus pi over 2 is negative pi over 2. Pi over 2 minus pi over 2 is 0. 1 minus 1/2 would be pi over 2. Or 2 pi over 2 minus 1 pi over 2 is pi over 2. 3 pi over 2 minus pi over 2 would be 2 pi over 2, which is just pi. 2 pi minus pi over 2, this would be 4 minus 1, which gives me 3 pi over 2. So normal cosine curve goes up, but this one has a minus sign in front, so it's going to start in the negative direction, -1. Then we have our 0, which is our asymptote. And then we go -1, but negative and a negative is going to make that a +1. Then we have a 0, which is our asymptote. And then 1 times -1, again, going to be -1. So we're going to have an asymptote at 0. We have an asymptote at pi, which means we're also going to have an asymptote at 2 pi, if I could draw straight. Don't have negative pi over 2 to graph. At positive pi over 2, we're up at 1. And at 3 pi over 2, we're down to -1. Again, when I hit my graph button then, I'm going to have something that sort of looks like that, which is going to be the graph of my secant curve. All right, sketching the graph of a tangent or cotangent function. First of all, you might want to know what the graph of a tangent or a cotangent function looks like. If I have my tangent function, normal graph of a tangent function has a period of pi. Sine and cosine had a period of 2 pi. Tangent and cotangent will have a period of pi. Tangent, the middle is going to be right here at 0 at negative pi over 2, and at positive pi over 2, you're going to have your asymptotes. For your normal tangent curve, you are going to start on the negative, end on the positive, and your graph is going to look something sort of like that. Cotangent curve. Cotangent curve looks a whole lot like the tangent curve. It's just pushed over and then it starts in the positive and ends in the negative. So for my cotangent curve, my period again is pi, so it's going to go from 0 to pi. My asymptote's going to be right on 0, although my line didn't want to draw there. Halfway between that, so at pi over 2, it's going to be at 0. It's going to start on the positive, end on the negative, and so my graph is going to look something sort of like that. So if I'm going to graph my tangent curve, I'm going to start with my main points of my tangent graph. I have negative pi over 2. Halfway between here and here would be negative pi over 4, 0, positive pi over 4, and then positive pi over 2. At negative pi over 2 and positive pi over 2, you're going to have your asymptotes. At 0, you're going to be at 0. At negative pi over 4, you're going to go down the amplitude normally. And at positive pi over 4, you would go up your amplitude normally. So, just like we did when we graphed the sine and the cosine curves, we're going to take our shifts, set them equal to our normal x values, and solve. So, I'm going to say x minus pi over 2 is going to equal negative pi over 2, going to equal negative pi over 4, going to equal 0, going to equal pi over 4, and going to equal pi over 2. So if I'm going to solve those, I have to add my pi over 2 to each of those x values. So if I add my pi over 2, negative pi over 2 plus pi over 2 is going to give me 0. Negative pi over 4 plus pi over 2. So this would be 2 pi over 4. Negative 1 plus 2 is going to give me a positive pi over 4. 0 plus pi over 2 is pi over 2. Pi over 4 plus pi over 2, again, this would be 2 pi over 4. So 1 plus 2 is going to give me 3 pi over 4. And pi over 2 plus pi over 2 is 2 pi over 2, which is just pi. So again, thinking of your fractions, negative 1/2, positive 1/2, just ignore the pi, and so forth. First one's going to be my asymptote. The next one, I'm going to take negative 1 times my amplitude of 2, so negative 2. The middle one's going to be at 0. Then I'm going to have positive 1 times my amplitude of 2, and the end's going to be my asymptote. So my asymptotes are at 0 and at pi. At pi over 2, halfway between my two lines, I'm crossing the x-axis. And then at pi over 4, I'd be at negative 2. At 3 pi over 4, I'm going to be at positive 2. And my tangent graph is going to look something sort of like that. Number 8, we are going to do a cotangent graph. So thinking about my normal values for cotangent, cotangent starts at 0 and ends at pi, has a period of pi. Halfway between pi over 2 is where I have my 0. So this would be pi over 4. This would be 3 pi over 4. And so I have an asymptote here, asymptote at the end. With my cotangent curve, normally I start on the positive end and end in the negative end. So those would be my normal standard values for cotangent. So cotangent of x plus pi over 3. So x plus pi over 3, we want to set equal to 0, equal to pi over 4, equal to pi over 2, equal to 3 pi over 4, and equal to pi. And then we want to solve each of those. So we are going to subtract our pi over 3 in order to solve each of those. So subtract our pi over 3, pi over 3, almost can read that. So 0 minus pi over 3 would be negative pi over 3. 4 pi over 3 minus pi over 3, I'm going to put them over 12. 4 goes into 12 3 times, so 3 pi over 12. 3 goes into 12 4 times. 3 minus 4 would give me negative pi over 12. Here I'm doing 2/3, so I've got to put them over 6. 2 goes into 6 3 times, so 3 pi. 3 goes into 6 2 times, so 2 pi. 3 pi minus 2 pi is going to be 1 pi over 6 then. Here again we've got to do 12s. 4 goes into 12, 3 times 3 is 9. 3 goes into 12 4 times. 9 minus 4 gives me 5 pi over 12. And then we've got pi minus 1/3. 1 minus 1/3 would be 2/3, so 2 pi over 3. First one's going to be an asymptote. Last one's going to be an asymptote. Middle one's going to be 0. For my cotangent curve, I'm going to take 1 times my amplitude, which is 1 in this case, gives me 1. Negative 1 times my amplitude, going to give me negative 1 there. So my asymptotes at negative pi over 3 and 2 pi over 3. Well, you'll notice I don't have any over 3s. I've got to figure out what units I'm in. In this case, if I count from 0 to pi, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of my marks is pi over 12. Negative pi over 3 would be negative 4 pi over 12. So 1, 2, 3, 4 marks. That's where my negative pi over 3 is, so I can put my asymptote. Positive 2 pi over 3, if I put it over 12, would be 8 pi over 12. So positive 8. 1, 2, 3, 4, 5, 6, 7, 8. That's where my asymptote's going to be. Pi over 6 would be 2 pi over 12. So at 2 pi over 12, I should be at 0, halfway between each of my asymptotes. Looks like that's halfway between each of my asymptotes. At negative pi over 12, which is just back 1 mark, I'm up to 1. And at 5 pi, 1, 2, 3, 4, 5 over 12, I'm down to negative 1. And so my cotangent curve in this case looks something sort of like that. I'm not very good with my curve, but when you hit the graph button on Alex, it'll draw it nicer than I can draw. It's going to look something sort of like that. So here are my starting values for cotangent. We had the other ones for tangent, and we're going to do tangent again. So number 9, we are graphing y equals the tangent of x plus pi over 6. Normal tangent graph starts at negative pi over 2, ends at positive pi over 2. Has a period of 1 pi. Halfway between is going to be the 0. 0, 0 is going to be the middle of my graph. Negative pi over 4, positive pi over 4. So we said 0, 0 is the middle. That at the beginning and the end we're having our asymptotes, just like on the cotangent curve. With the tangent curve, normally you start in the negative direction, end in the positive direction. So, x plus pi over 6 is going to equal each of my starting x values. Negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. If I'm going to solve, I'm going to subtract pi over 6 from each of my values. And then I'm going to do my adding and subtracting with my fractions. Ignore that the pi is there. Think of it as 1. A negative 1/2 minus 1/6. I'd have to have twelfths. 2 goes into 12 6 times, so minus 6. 6 goes into 6, or 6 goes into 12 2 times, so minus 2. Negative 6 minus 2 would give me negative 8/12 pi. I can simplify my fraction because I can divide by 4, so negative 2 pi over 3. On the other one, again, I would have a common denominator of 12. 4 goes into 12 3 times. 6 goes into 12 2 times. So I'm going to get negative 5 pi over 12. Here I'm just going to have negative pi over 6. Here again I've got, here I've got a positive pi over 4. I thought I had the same thing up there, but that had a negative. So again, I'm going to put it over 12. 4 goes into 12 3 times. 6 goes into 12 2 times. 3 minus 2 is a positive 1 pi over 12. And then here, if I go over 12, 2 goes into 12 6 times. 6 goes into 12 2 times. I get 4 pi over 12, which would reduce down to pi over 3. So we know that at the beginning we're going to have our asymptote. At the end we're going to have our asymptote. In the middle we have 0. Here we're going to take negative 1 times our amplitude, which is 1, so negative 1. And then 1 times our amplitude is 1. So asymptote is at negative 2 pi over 3. Again, we don't have them over 3. And if I count, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't quite fit on there, but it is twelfths that it is in. It's just hard to see. So negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 pi over 12 is going to be where my first asymptote is. That's what we had here before I simplified. If you think about this, from 0 to pi over 4, which is 1/4, there is 1, 2, 3. So if I divide that by 3, 1/4 times 1/3 means each of those marks are 1/12 of my way. Negative 5 pi over 12, 1, 2, 3, 4, 5. I'm going to be at negative 1. Pi over 6, or negative pi over 6 would be negative 2. That's where I'm at 0. Positive pi over 12, I'm at positive 1. And then at pi over 3, which would be 4 pi, 1, 2, 3, 4 over 12, I have my other asymptote. So my tangent curve is going to look something sort of like that. And again, if you're not sure where the marks are, you can always use the plot point tool for the dots. You can actually use the plot point tool here and do something like negative 2 pi over 3 and 0. It would put an X there so that you know that you can erase the X and put your asymptote on top. So if you're not exactly sure where that line is on Alex, plot it as a point to get a dot on your graph. Then you'll know where that line is. And continuing on, graphing y equals negative 1/2 tangent of 2/3 x. Again, we're going to graph the tangent and the cotangent functions, and this time we have a different period on there that we're going to stretch our graph out. But we're going to do the exact same thing we were doing before. Since this is the tangent graph, my normal values for tangent, negative pi over 2, negative pi over 4, 0 in the middle, pi over 4, and pi over 2. With my tangent graph and my cotangent graph, I'm going to start and end with my asymptotes. 0 is going to be in the middle. For my tangent graph, I'm going to start in the negative, end in the positive. Unless we start with a negative up there. We'll get to that. So, again, we take the part in the parentheses, the 2/3 x, set them each to our x values here, negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And then we have to solve. So we would divide by 2/3, which is multiplying by 3 over 2. So I'm going to multiply each of these by 3/2. So this is going to give me negative 3 pi over 4. This is going to give me negative 3 pi over 8. This is going to give me 0. This is 3 pi over 8. And this is 3 pi over 4. So, between 0 and pi, 1, 2, 3, 4, 5, 6, 7, 8. Each of those are in pi over 8ths. And so, first is my asymptote. Last is my asymptote. 0 in the middle. Here I'm going to take negative 1 times the value in front of the tangent. Since I have a negative times a negative, it changed to a positive. Positive 1 times the value in front of my tangent. So I get negative 1/2. So at negative 3 pi over 4, these were over 8, so I'd have to go negative 6. 1, 2, 3, 4, 5, 6. Here would be negative 3 pi over 4. And at positive 3 pi over 4. So 1, 2, 3, 4, 5, 6. 6/8 is the same thing as 3/4, right? Negative 3/8. 1, 2, 3. I'm at positive 1/2. That one you have to use the plot point tool on. 0, 0. And then positive 3/8, 1, 2, 3, I'm at negative 1/2. So you'll notice here that this is in the middle of this is in the middle. They each just kind of split each other into parts. And then when I hit my graph button, it looks like the cotangent function because it's coming from the top and going to the bottom, but it's actually the tangent function. It just got flipped because of the negative in front of that tangent there. So on number 11, we are going to graph the tangent function again. Tangent function starts at negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. We have an asymptote at the beginning and an asymptote at the end. 0 in the middle, starts negative, ends positive. So we have 2x, all right? Normally that would be in parentheses, but we don't need it on this one. 2x to equal our negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So we want to solve this one for x. If I'm going to solve it for x, I'm dividing by 2. Dividing by 2 is multiplying by 1/2. So I'm going to multiply everything by 1/2. The reciprocal of 2 is 1/2. So I get negative pi over 4. I get negative pi over 8. I get 0, pi over 8, and pi over 4. So we are doing the tangent. We have an asymptote at the beginning and an asymptote at the end and 0 in the middle. We're going to do negative 1 times our amplitude, so negative 4 to start, then 1 times our amplitude, so positive 4 to end. So asymptotes at negative pi over 4, positive pi over 4. They had those marked good for us. 0, 0 in the middle. At negative pi over 8, I'm down at negative 4. At positive pi over 8, I'm up at positive 4. And so my tangent graph this time looks something sort of like that. And then we're going to do a cotangent graph. So on our cotangent graph, our cotangent starts at 0 and ends at pi. 0 to pi would be my normal graph. Pi over 2 is in the middle, so I would have pi over 4 and 3 pi over 4 for my other values. Again, I have an asymptote at the beginning and an asymptote at the end. 0 in the middle. The cotangent starts in the positive, ends in the negative on my normal cotangent curve. So, in my parentheses, I have 2/5 x to equal each of those values. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. I have to solve that for x, so I would divide by 2/5, which is multiplying by 5 over 2. So 0 times 5 over 2 is still 0. Then I'm going to get 5 pi over 8. Then I'm going to get 5 pi over 4. Then I'm going to get 15 pi over 8. And then I'm going to get 5 pi over 2. So asymptote at the beginning, asymptote at the end, 0 in the middle. 1 times 1/2 is 1/2. Negative 1 times 1/2 is negative 1/2. Almost can read the negative. I'm going to put it out there. So asymptote at 0. Asymptote at 5/2, which they happen to have marked, so I don't have to figure that one out. 5/4. 1, 2, 3, 4. I'm in eighths, so I'd have to go 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be halfway between. It looks like it is. Should be right at 0. 5/8. 1, 2, 3, 4, 5, which should be halfway in between. I'm up to 1/2. And then I'm at 15/8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm down to negative 1/2. And my cotangent curve is going to look something sort of like that. Using cofunction identities, it says use a cofunction to write the expression that's equal to the cosecant of 20 degrees. Sine and cosine are cofunctions. Tangent and cotangent, secant and cosecant. So Whichever this is, you're going to use the opposite one and then take 90 or pi over 2 minus the angle. So in this case, since I have cosecant, I'm going to have the secant of 90 minus 20. So I get the secant of 70 degrees for my cotangent, or for my cofunction to the cosecant of 20. 14 says use a cofunction to write an expression equal to the tangent of 2 pi over 5. Tangent and cotangent are cofunctions, and so I would use cotangent, and instead of 90, I'm going to use pi over 2 minus my 2 pi over 5. So 1/2 minus 2/5. Find my common denominator. 2 goes into 10 5 times. 5 goes into 10 2 times 2. And so 5 pi over 10 minus 4 pi over 10 is just pi over 10. And so I get the cotangent of pi over 10. That is the cofunction that's equal to the tangent of 2 pi over 5. If I would find those two values, I'd get the exact same answer for both of them. And use my cofunction to write an expression equal to the sine of 3 pi over 7. Sine and cosine are cofunctions, so I'm going to do the cosine. Again, since I'm in radians, I'm going to take pi over 2 minus 3 pi over 7. And so 14 would be my common denominator. 2 goes into 14 7 times. 7 goes into 14 2 times 3. So 7 minus 6 gives us pi over 14. So my cofunction that's equal to the sine of 3 pi over 7 would be the cosine of pi over 14. So, fairly easy there. If you know the cofunction is either 90 minus my angle or pi over 2 minus my angle, sine and cosine, tangent and cotangent, secant and cosecant are cofunctions.